Gomecsys is a Netherlands-based company dedicated to developing fuel-saving engine technology. Our latest VCR technology saves a staggering 18% off fuel compared to today's modern engines, and it reduces CO2 emissions by 18%. This allows car manufacturers to build more efficient engines in accordance with the emission standards of the future.
Here at Gomecsys we developed our own VCR technology. VCR meaning variable compression ratio. In normal engines the compression ratio is fixed, so normally that's 10:1 in a normal engine that's made for peak performance, a maximum load. And to increase the efficiency of an engine when you drive 50 km an hour in the city, you would like to use 16:1 or even 18:1. So how we realize variable compression ratio is that we use an eccentric between the crank pin and each conrod. And by changing the position of this eccentric, we can lift or lower the conrod and change compression ratio between 18:1 to 8.5:1 or 8:1. And the effect of that is about, in our case, 18% less fuel consumption.
There is another benefit to our variable compression ratio technology. It makes it possible to downsize engines without losing performance. Downsizing is one of the biggest trends in the automotive industry today, as smaller engines weigh less and lose less power to internal friction and pumping losses. A downsized engine, however, needs to be boosted to achieve the same power as bigger engines. This can only be done in combination with a low compression ratio, optimal for driving at high loads, but very inefficient when driving at lower speeds. Our variable compression ratio technology can provide the high compression ratio for driving in the city and a low compression ratio to deliver the performance drivers expect out of their engine, even in an extremely downsized engine.
I've been involved with Gomecsys for about a year now, and we've together tried to engage the market and try to use the network worldwide actually to get attraction for this technology. I think an 18% efficiency gain is just incredible. The good thing about this fuel-saving technology is that it can actually be implemented alongside other fuel-saving technologies. Furthermore, this technology fits in existing engine designs and builds, so it can be implemented and tested very easily without large investments. I think this is the most cost-effective near-future technology solution, which only comes at about €5 per gram CO2 reduction. I think this will be the industrial standard for the next generation cars.
Gomecsys has won several prizes for its innovation, as well as a Eureka Dutch government grant of €1.5 million. Throughout several partnerships, for instance with ProDrive, Gomecsys has been able to advance their VCR technology from theory to practice. Ideas for variable compression ratio engines have been around for decades, but there were always problems that have led to efficiency losses rather than gains. The Gomecsys VCR technology is, compared to other VCR designs, in itself a simple and minimal alteration to current engine technology. This minimal alteration, however, proves to be very effective in overcoming traditional problems in VCR design. The secret lies in an eccentric between the crank pin and the big end of each conrod. This gives us 4 advantages. Primarily the variable compression ratio itself, which is achieved by turning the eccentric up and down. Secondly, the eccentric allows for an overexpanded engine cycle after combustion, giving more power to the piston during the expansion stroke. Also, when running at high compression ratio, TDC gas exchange is lower than normal, giving a shorter intake stroke, thus reducing pumping losses. This is the third advantage. Finally, and this may come as a surprise, because the eccentric runs at half the speed of the crankshaft, the 2 bearings in and outside the eccentric also run at half the crankshaft speed, therefore creating less friction than there would normally be in a system with a single bearing. So in all, this one modification offers 4 advantages, making it more than just another VCR.
When car manufacturers visit us here, they are very surprised by the huge development process we already went through the last 10 years. And it's of course a concern to them that we have a press-fit crankshaft, an assembled crankshaft. But we always point out to them that that's already proven technology. It has proven itself in, for instance, Harley-Davidson engines, or in Citroën boxer engines in cars like the GS or 2CV. So that's certainly a challenge, but it's proven technology. This year we equipped a Mitsubishi Colt with one of our VCR prototype engines, and we do that because we want to test and demonstrate the engine, of course, on the road. And so far it has been working incredibly well. So if you want, we can take it for a spin. When I drive slowly with little load, here you can see the intake manifold pressure is only 450 millibars and compression ratio is 16.7, 16.8. So when I accelerate, you can see the compression ratio going down and the intake manifold pressure going up. I'll do it again. So here you have very low intake, so you have vacuum. 400 millibar, and then when you accelerate, you can see intake pressure going up to 2 bar. We can apply this technology to all sorts of engine, 2-cylinder, 3-cylinder, 4-cylinder, V8, there's no difference. And also, you know, combined with downsizing, applying it on a 3-cylinder instead of a 4-cylinder engine gives space for hybrid system to make the powertrain even more efficient.
Well, the good thing about Gomecsys is that they didn't stop after the first engine development. They continued on for 12 years. This engine is more efficient than any of the competitors' similar technology developments. Furthermore, Gomecsys proved with their tests that they actually met the predictions. This is what makes the VCR technology of Gomecsys a success.
We started with our first prototype in the year 2000, but we didn't stop after one prototype. We went on and learned from our mistakes. For instance, on our first generation we had a friction problem because the eccentric was running at the opposite direction of the crankshaft. So now we run the eccentric the other direction and have less friction than normal engines because this eccentric runs half of the speed of the crankshaft. And so with the development we solved all the basic problems and now it's working and good developed technology. There is absolutely no modification needed to the engine block, and this is very important for car manufacturers. The only thing that needs to be changed is the crankshaft. So we started a cooperation with a leading European car manufacturer, and we are open to, or we are ready to start cooperation with other car manufacturers worldwide as well.
12 years of development took the Gomecsys VCR technology to where it is today. Now we're looking to take it a step further, to take this design into production, cutting costs for the consumer and reducing 18% of CO2 emissions for the world tomorrow. A small change can make a big difference.